Well, ladies and gentlemen, welcome back here to skill 17. This is called the quotient rule. So quotient rule, very similar in a lot of ways to the product rule, except the formula is a little bit different and you're dealing with a quotient type of scenario. So maybe I give you a function to take the derivative of. So like an example could be, let's go big, bad, and ugly. Let's do like 2x to the fifth plus 4x to the fourth over 3x squared plus 2x. I'm just making stuff up here. So this would be a quotient rule type of situation. So when you have a situation where you have like an f of x and a g of x, and this is the formula that you would see in a textbook, but I have some really clever ways to memorize it. And it even adds a little charm and character to it. So that's what we're going to see right now. So actually, my dad, who graduated from high school way back in like 1968, and took calculus like that next year, first year of college, his calc professor had a very clever way to memorize it. So he said, low d high minus high d low over low low. That's low squared. And he used to like get up on fours or something and like chant it out to get them to memorize it. So I even have a little cute cartoon. You could think of Alice loved this cartoon, Snow White and the Seven Dwarfs. So like low-de high, ho-de high, minus high-de ho over ho-ho, where ho is low. That's quotient. All right. So let's actually look at one of these bad boys. So I say bad boy because we see fractions and, we freak out. But I promise it's not bad. So this is actually a very similar thing to the product rule. So call this your F part and call this the G part. So a lot of your dirty work is going to be the same as the product rule. And I always like labeling my F and G. Right, F prime is 5. G prime is 2x. So then I have low d high minus high d low. So low is G. Gf prime minus high, which is Fg prime, high d low over low low. So this just means that we're squaring. And then I just put in all the ingredients. So I have x squared minus 1 times 5 minus 5x plus 2 is 2x. And in my g prime, or g squared, I have x squared minus 1 squared. And you can actually leave your final answer just like that. And you are 100% done. Let's take a look at another example. This one actually looks a little bit worse because we have a fraction within a fraction, but I promise you it is not that bad. So write this as instead 1 over x is x to the negative 1. And the bottom part really isn't too bad at all. So that's your f, there's your g. So my f is going to be 3 minus x to the negative 1. My f prime is going to be 1 x to the negative 2. And then my g is x plus 5. My g prime is going to be 1. So then I kind of just write that formula. So the derivative formula would be low D high, so G F prime minus high D low, so F G prime over low squared, so that's G squared. And I just put that in. So my G is just X plus 5. My F prime is going to be 1x to the negative 2. And you're going to subtract 3 minus x to the negative 1 times G prime, which is just 1. That's over x plus 5 squared. Now, if I don't want fractional exponents, you can just get rid of those fractional exponents and just call this 1 over x squared. And then on this one, I would just call it 3 minus 1 over x, kind of the way that it was written, times 1. That just doesn't really change anything. And really, that's about the only type of curveballs that we throw in when you get those like negative and radical exponents. So the better you are at power rule, the more you can be exposed to with the quotient rule, so to speak. So do we always, are we always in a position where we need to use the quotient rule? Well, there's actually some situations where it may look like a quotient rule, but you may be more advantageous to use the power rule. So let's look at this type of situation. Let's go to like 5a here, this example. So I could actually rewrite this as one-sixth x squared plus 3 over 6 x. And then I just differentiate. So let's see, this would be 2/6 x plus 3/6. And then you want to make sure that you are simplifying your fractions. So let's see, this would be 1/3 x plus 1/2. And let's see, this is your y prime. And this is kind of y prime here too. So you don't need to always be using the quotient rule there. Let's look at this one. So for this one, if I kind of like multiply things out here, multiplication really isn't that bad. So I have negative 9x plus 6x squared over 7x. So I'm just going to rewrite this as negative 9x over 7x plus 6x squared over 7x. So this would just be like negative 9/7 plus 6 over 7x. And then when we differentiate that, we just get 6 over 7. So moral of the story here, just because something is written as a quotient doesn't mean that you always have to use the quotient rule. Because sometimes, when you have a situation like these, you could just use some simple properties of exponents or very simple multiplication and turn it back into a power rule type of scenario. So on delta today, you'll just have some quotient rule. Just pay attention to the directions on your delta. And also, just because something is written as a quotient doesn't always mean that it's the quotient rule. If you can simplify it and write it into that power rule type of form, go ahead and do it because it can actually make your life a lot easier. Now, if you actually did quotient rule on these, would you get the wrong answer? Actually, the answer is no. You would get the right answer, but it would just take you a little bit more time. So as we get through these derivatives, your goal is to become not only good at computing these derivatives, but also thinking about how do you compute the derivatives most efficiently, and really think hard about what rule you are using. So the rules that we know now are power, product, and quotient. We look forward to next week learning one more rule as well. So thank you very much and have a great day.